One of the main differences when we are studying solubility equilibria with other kinds of equilibria is that when everything is dissolved, the equilibrium constant is always constant. There is no way that one cannot have an equilibrium constant. That is not the case when you're having equilibria with compounds with limited solubility. And this is why we will recover the concept that you learned last semester in solving equilibrium problems, QSP. The difference between QSP and KSP is that they both have the same expression, just that KSP is only applicable when it's in equilibrium. The QSP is the solubility product when it's not in equilibrium. So it has the same expression as the KSP, just that in here you will put the concentrations that exist in that specific moment. And you have three different cases. You can have when the QSP is smaller than the KSP, when it's equal, and when it's larger. Alright, so let's see. Well, we have actually three different cases. One, if the QSP is smaller, it means that your solution is unsaturated. What does that mean? It means that if you have a beaker and all your ions are dissolved, it means there is no precipitate, there is no solid at the bottom, no precipitate at the bottom. It means that there is no way for the solution to reach the KSP because there's not enough ions in solution to form a solid. Okay? In that case, because there's not enough ions in solution, the product of concentrations will be smaller than the KSP. We say that the solution is unsaturated. It can admit more ions and they will still dissolve. To the point that when the QSP is equal to the KSP, that's called saturated. It means that the solution has reached the maximum number of ions that you have in solution, and you can have solid or not solid. So you may have no solid if you have very slowly have added the amount of solid that you're right at that point where there's no solid yet, and yet the solution is saturated. You could have a solid if you have passed that point, but then all the solid that you're adding, it accumulates. We say that the solution is saturated because it's in equilibrium with the solid, in equilibrium with the liquid. There's a rare case in which you have a supersaturated solution. You will have only a supersaturated solution when, for whatever reason, and that's more of a kinetic reason, that the ion, there's way too many ions in solution and they should precipitate. You may have sometimes actually, most of the times, it's when you have a solution when it has way too many ions, but they have not read the book and they do not know that they should be precipitating. I'm kind of joking here because this is called a non-equilibrium situation. A small disturbance to this equilibrium, it will make precipitate the solution right away. Okay, so eventually this will go back to a saturated solution. All right, these three cases will help us understand at what point the saturation is. Is it unsaturated, saturated, or supersaturated? If it's supersaturated, eventually it will go back to saturated. Notice that if it's unsaturated, unless you throw anything else, and unless you dissolve more of the solid, it will never reach the saturated point. Alright, let's try to solve a problem. This is a typical problem in which we're being asked if there's going to be any solid being formed. Let's read it. So there's a common laboratory method for preparing a precipitate is to mix solutions of the component ions. Good. Does precipitate form when we mix this much of calcium nitrate, both solid, remember that nitrates are soluble, and this much of sodium fluoride? Well, how much is the concentration of calcium? Right? Notice that the total volume, because I'm mixing 1 liter and 0.2 liters, the total volume will be 0.3 liters. Alright? How many moles of calcium do I have? The ratio would be 1 to 1 if it's 0.3. So I have 0.1 liter times 0.3 molar. This will be 0.03 moles. So the concentration will be 0.03 moles divided by 0.03 liters. In other words, the concentration of calcium, will be 0.01 molar. Okay. What is the concentration of fluoride? Notice that I'm only going for the calcium and fluoride that interest me. So the concentration of fluoride will be, I have 0.3 liters in total. The number of moles of fluoride will be 0.06 molar times 0.02. In other words, let me do 0.06 times 0.02. No, it should be 0.2 liters. I'm sorry. So this should be 0.2 liters. Yeah, 0.2 liters. So 0.06 times 0.02, that's 0.012. 0.012 molar. Sorry, 0.012 liters. Not liters, sorry, moles. Okay. And that divided by 0.3 liters, I have 0.04. The question is, will there be a precipitate forming with these concentrations? Well, the QSP, which has the same expression of the KSP, is concentration of calcium times concentration of fluoride square. Concentration of calcium is 0.1 times concentration of fluoride square. How much is this? Let me see. 0.1 times 0.04 square, and that's equal to 1.6 times 10 to the negative 4. Okay, this is much larger than this KSP. The QSP is much larger than the KSP. This is supersaturated. It means that there'll be solid will form. Okay, because we have way too many ions in solution. This solid only admits these many ions, therefore we have too many. We have a way to predict that there will be solid forming.